Welcome to the PhysicsPlace. In this video I'm going to explain what gravitational potential energy is, or potential energy in short, and how you can calculate with it. And it has something to do with this guy standing on a building and with these books which have a different height and, as you can see, a different mass. Gravitational potential energy, or in other words stored energy, is the energy an object has due to its position or state. So if we have these books here on the table, they have a certain amount of energy because they are in this position. If they would be lower, they would have less energy, and if they are higher, they would have more energy. And you can imagine this: if you would drop them and you will drop them on your toe, then these books will hurt less than these books, and the fact that these books hurt more are because they have more energy. Of course, you can also add even more energy to it, but first, the difference in height is one of the factors which says about the energy. The second thing is the mass. If you have more books, so if they are heavier and you drop them, then you can imagine that it will hurt even more. So also the mass has something to do with the potential energy. So the difference in height and the mass have these are very important for the potential energy. And finally, the gravitational acceleration, so the pull. You can imagine if you would be standing on a different planet where the gravitational pull would be less. For instance, if you are on the moon, it will be 1/6 of what we have here on Earth. Then these books will fall a lot slower, so they will hit your toes with a different velocity, so it will hurt a lot less. So also the gravitational acceleration is important for the potential energy. These combined are into one equation, and it looks like this. So we have the potential energy. And the potential energy is measured in joules. All the energies are measured in joules, so that's easy. So also the potential energy. Then we have the mass. The mass is always measured in kilograms, very important. We have g, the gravitational acceleration, which on Earth is 9.8 meters per second square. This one differs on different planets. On the moon it's 1.6. On Mars I believe it's 3.4. I'm not 100% sure, but it's a lot less. And on Earth it's just a number 9.8. So this is always a number 9.8 if we are on Earth. And this one, the h, it's the height of the object, and that one is in meters. I forgot to put it here, but that's in meters. So we have this, the mass in kilograms. This one is a number 9.8, and this one is in meters. And the potential energy is in joule. An example, we have a book with a mass of 2.3 kilograms, or we have multiple books, and they are on a table with a height of 1.2 meters. Calculate their potential energy. So you can try this for yourself. Get a calculator, get some paper and a pen, and try to calculate the potential energy with the equation I just gave you. Well, first we have the mass 2.3 kilograms, we have the height 1.2 meters, and it isn't given, but we are on Earth, so the acceleration due to gravity is 9.8 meters per second square. If it's not given in the question, then you should just see this as a default. It's always like this. So we have the equation. We can put our data into the equation. So we have 2.3 multiplied by 9.8 multiplied by 1.2, and we have 27 joules. So the energy, the potential energy these books have is 27 joules. And of course, if you will put them higher, then the height will go up, so their energy will go will become larger. And of course, if you make them heavier, then also the energy will become larger. Another example: John has a mass of 65 kilograms, and he needed 16.6 kilojoules energy to walk up this building. Calculate the height of the building. So he started here, and then he needed 16.6 kilojoules to walk up with his mass, and you can now calculate how high he went. Try this for yourself. The answer I will give it now. We have the potential energy, it's 16.6 kilojoules. Of course, we have to convert this to joules, so it's 16.6 multiplied by 1,000, because the kilo is 1,000. You can also do it like this if you find it easier. And we have the mass, 65 kilograms. We have the g, it's not given here, so we just use the 9.8 meters per second square because we are on Earth. And we have this equation, and we need to calculate this letter. We have to calculate the height. So we can put all the information in which we already have here. So 16.6 multiplied by 1,000 equals 65 multiplied by 9.8 multiplied by the h. So this is the unknown one. This we can put into the equation in our calculator, and it will look like this. It's together 637. Now we divide both sides by 637, and we have the height of 26 meters. Very important, the meters here. So he has a height of 26 meters. And the final example. An airplane needed 18 gigajoules to get to a height of 10 kilometers. Calculate the mass of the plane. I don't know if you already had giga, but giga is 1 billion. So if you have 18 gigajoules, then it's 18 billion joules. You can write it like this, or with a lot of zeros, 9 to be exact. We have the height, 10 kilometers. Of course, it needs to be in meters, so we have to convert it, multiply by 1,000. So we have 10,000 meters. You can also write it like this. And we have, of course, the acceleration due to gravity, 9.8. This is the equation. If we fill in the equation, it looks like this. So we have 18 multiplied by 10 to the 9th, the mass, which is unknown, and 9.8 is the gravitational acceleration due to gravity, and we have the 10,000 meters. This we can calculate, so it will look like this. We just add the 0 here, so the 3 becomes a 4. Now we have to divide by this number, and then we will know the mass. And the mass will be 183,637 kilograms. I don't know if significance is important. If so, then you have to write it like this. If that's not important, if it doesn't say anything, then you can just give this an answer. And if significance is important, then you have to write it like this. That's it. I hope you now know what potential energy is and how you can calculate with it. If you found this video helpful, please let me know by liking and of course subscribe for more videos. Thanks for watching.